Lab 3, technical presentation by Group 5. Our first task is to identify the midterms. We do this by entering the truth table into this K-map tool. Use the loop color to highlight any of the variables that are true. We go through and continue to do this for each output that we need. In this K-map, you can see that there will be 3 loops. The trick with the K-map loops is to ensure that you select the largest loop possible. This will help us when we are designing our equations. We're going to continue to go ahead and do that for the next 2 parts as well. The next step in the lab is to prepare our minimized equation. When we're doing our equations, we want to look at what stays constant. So we can see that in SL we have S naught and L naught as well as S and L. So C and R are the only variables that stay the same the entire time. So for the right back equation, we look at the inputs for each loop. There's the same one as we had before, so that's our CR. And we're going to continue with our second loop here. We see that SL stays constant, which gives us the LS. All of the RCs change, so we can keep just that SL, which gets converted into the LS when you get ready to put it into iLearn. And then for our last loop, we look here, and we have this cube. So we see that S and R naught remain constant. We continue to do this with the last 2 equations as well. Part of the lab involves designing the circuit in LogSim. So we take each of the terms that we had in our equations and we use them to create these gates. We're going to need 4 inputs for our stop, left, right, and clock. We're going to need 2 knots so that we can have our left knot and our right knot. And then we're going to need 6 AND gates, 2 OR gates that have 3 inputs, and then our 4 outputs, which is what the lights are going to do. So as we go through each of our equations, we ensure that the wiring is correct so that we are getting the same outputs as the equations that we just determined with our K-maps. You can see the Boolean equations here. For our left front, we had CL, so we have the clock and we have left. So if we wire them here, we have clock and left, which comes over here and outputs for our left front. For our left back, we have 3 terms, so we're going to go through 3 gates. We have our clock left, which is going to come here into this OR gate. Remember that the 2 together is AND. If we have the plus symbol, then that means OR. So we have clock left or stop right or stop left not. So stop right, we need to take our stop over here and our right, and we have our AND gate, which is feeding into our OR gate here. And then for our last, we have SL naught. So in order to get that L naught, we have to come up here and add our inverter to take that from L to L naught, and then we have stop coming in here. This all feeds into our OR gate and into our output. Continue to do that for the last 2 variables as well. On the discussion boards, the trickiest part of this lab was the ROM circuit. Now, taking the truth table, you can get the hexadecimal values. We're going to need that for the ROM circuit. And we apply them like this. So the ROM circuit stores the value in here in the center based on what the input does, what the output should do here. And we had to do a 4-input splitter and a 4-input splitter in order to have our inputs and outputs. Now, some people had a hard time with editing the editor. Sometimes you could click in here and edit it, and sometimes you had to go into this hex editor. Let me show you how to do that. Also worth noting, depending on how you configured your splitter, with your least and most significant bit is going to change what your input is in here in the ROM. So if you need to change the splitter, you can come down here and bit 0 is going to be on the bottom or on the top. You can adjust that way for your most significant to least significant bits. To edit this information here in the ROM, you right click, go to edit contents. It pulls up this hex editor window and you can type in here directly. When you hit close window, it saves all of the information. Hopefully this tutorial has been helpful and answered any questions you may have had about this lab. Thank you very much.